Alright, so we see that this is question 1986, question 1. And even though we did this one class, I'm still going to go ahead and go through this one again. So we've got 3 blocks of masses 1, 2, and 4 kilograms. They're connected by a massless string, which only happens in physics world, over a frictionless pulley, again, only in physics world, and calculate each of the following. So the acceleration of the 4 kilogram block. So we see that all of these are connected, and we see that the 4 kilogram block is connected to this 2 kilogram block, which is connected to this 1 kilogram block. And so we see that because this side is heavier than this side, we're going to have an acceleration pointing down like that on that side. And if our acceleration is pointing down on this side, that means that our acceleration must be pointing up on this side. And so we see that this acceleration is going to be the same because they're part of the same system right here. And so basically what we need to do is we need to set this up in a sum of the forces equation. And one thing that'll make our lives a lot easier is if we just go ahead and make these 2 blocks into one 3 kilogram block. Alright, so we're going to pretend like these blocks are just basically one 3 kilogram block, at least for this problem right here. And so let's go ahead and just look at the forces for this. So this, like I said, is one 3 kilogram block. And basically what we need to do is we need to set up an equation. So let's go ahead and do that. We've got the sum of the forces equals m, so the sum of the forces and this acceleration is going to be due to all of these blocks right here. The 4, the 2, and the 1. So they all add up to 7. So it is going to be our total mass and the acceleration of the entire system right here, which is going to equal, okay, so now is when we look at our different forces acting. So we see that the force going down right here in the same direction as our acceleration is this m4g, okay, and that's what's causing all of this acceleration, is this m4g, this unbalanced force. Now if this was also 4 kilograms, it would be balanced and we wouldn't have any acceleration, but this right here is more than that, so that's why it's accelerating like that. And so we've got this m4g. Now this tension right here, we could include the tension, but it really doesn't have anything to do with the acceleration. So what has to do with the acceleration is this mass over here and these masses over here. And so we see that these masses over here, their mg is going down as well. And we've got m3g, so you guys see how we wrote that m3g, but we see it's going opposite, in an opposite direction as our acceleration. So this is going to actually be subtracted. So we're going to subtract our m3g, just like that. So this is the equation that we come up with just by looking at this and by comparing these masses over here. So now we're trying to find our acceleration, so we need to divide both sides by mt. So let's go ahead and do that. And we see that our acceleration is going to be equal to m4g minus m3g, all divided by our mass total. And so now what we need to do is plug all of our stuff in. So our mass of the 4 is just 4, g is 10, mass of the 3 is just 3, g is 10 again, and then our mass total is going to be 4 plus 3, which is 7. And so we end up with this, when we multiply all of this out, we're going to end up with 1.43 meters per second squared. And that's going to be our final answer for this first part. Alright, so now we want to know the tension in the string supporting the 4 kilogram block. Now you guys, what we're going to do is we're only going to be looking at this 4 kilogram block. So let's go ahead and draw a free body diagram for this 4 kilogram block. And we see that we've got this tension T going up, and we've got this m4g going down. And we know that our acceleration is also going down like that. Okay, so now let's go ahead and do the sum of the forces equals, but this time since we're only looking at the 4 kilogram block, we're only going to be using this m4 times our acceleration. We're just going to equal these two forces, but we're going to do our m4g first because it's going the same direction. So we're going to make whatever way acceleration is pointing, that's going to be positive. So you're going to have m4g minus the t. All right, and we're looking for the tension. And so really what we need to do is just switch these two around, but let's just see how that looks. So we're going to add t to both sides. So we get m4, m4a plus t equals m4g. Now we subtract our m4a from both sides. And we get the t is equal to m4g minus m4a. And we could add another step in here. We could take this m4 out, so t equals m4g minus a. So we do that. And so then we say 4 times 10 minus 1.43, because we still use this 1.43 up here. And we should end up with tension of that string equaling 34.3 newtons. All right, now it wants the tension in the string connected to the 1 kilogram block. So now what we're going to do is we are only going to be looking at this 1 kilogram block. So let's go ahead and draw another free body diagram. So we've got tension going up. This time that's M1G, because this tension right here is only due to this M1G. And so now our acceleration this time, though, is going to be going up. So our sum of the forces, again, equals our M, but this time it's just M1A, which equals, now this time our T is going to be positive because it's going in the same direction as our A. It's going to be T minus M1G. And so we're again looking for T, so we're going to add M1G to both sides. So we get T equals M1A plus M1G, or we could just say T equals M1A plus G, and then plug that all in, and we get 1 times 1.43 plus 10, which is just going to equal 11.43 newtons. And we're done.